everyone. In today's video, we are going to talk about the intervals where a function increases, decreases, or is constant. So today you're going to learn how to find those intervals where the function is increasing, decreasing, and constant. And that's going to mean that we're also going to have to look at discontinuities and be able to identify them because they're going to complicate things just a smidgen. So we'll be looking at point discontinuities and also a little bit with asymptotes today as well. All right, so let's get into some vocabulary first. First, when we're looking for the intervals that a function is increasing, decreasing, or constant, we're always going to start by looking at the left-hand side of the graph, the negative infinity side of the x-axis, and we're going to read across to the right of the graph, the same way that we read words on paper. Everything that we're doing today is going to be about the x-axis. We're only going to use x values as answers in our intervals. Okay, so when we look across the graph from left to right, we start here where this arrow is on the negative infinity side, and if we follow this line, this section is increasing. It's going uphill. The y values are getting bigger. It's going up. So it's increasing until we get to this relative maximum, and then it changes directions because it's a turning point, and it starts going down and decreasing. So that section of the graph is decreasing. And then we have this little jump that happens. The line is changes. We have to pick up our pencil if we were going to start again on this piece. And this piece doesn't go up or down. It doesn't increase and it doesn't decrease. And that's what it means to be constant. The y values aren't changing at all as our x values move to the right. So we always read from left to right, and we're following the line, figuring out is the line going up, going down, or staying the same. Okay, so the piece that's going to make this a little bit more complicated sometimes is the idea of continuity. If a function is continuous, it means that there are no breaks in the graph. You can draw the entire function without picking up your pencil at all. So this shape here, this U shape that's upside down, that is continuous. If I wanted to do just a quick labeling, I would say this side is increasing until I get to that turning point, and then it begins decreasing. Again, you're reading from left to right to determine what's going up and what's going down. Now the discontinuities, that means there's a break in the function, or when I'm drawing it, I have to pick up my pencil in order to draw all of the line. So there are two types of discontinuities. The first that I'm going to talk about is actually the second one here, an asymptote. An asymptotic discontinuity is when you have a line that's getting really close to some value, but it never touches it. It just gets super, super close. Asymptotes are denoted by dotted lines. So you can see this line here is an asymptote. And what's happening on the left here is that our line, our function, it is going from left to the right. We're decreasing, we're going down. And then as it gets closer to this asymptote, it gets really, really close, but it doesn't ever actually touch it. The way that I like to think about this is if you have any siblings, you probably when you were younger played that game where you would annoy the bejesus out of your sibling by taking your finger or your foot or your shoulder or whatever and getting really, really, really close to your sibling, but not ever actually touching your sibling and saying, I'm not touching you, I'm not touching you, I'm not touching you. All right, that annoying game. Or maybe your siblings did it to you. That is like what the function is doing with this asymptote. The asymptote is that wall that is never going to actually be touched by the function. The same way that if you play that game correctly, your finger, for example, doesn't ever touch the shoulder of your sibling. So that's the first type of discontinuity, an asymptote. And the second is a point discontinuity. And a point is when you're going to draw a line, but you have to pick up your pencil to jump over a single ordered pair. So if you look at the right-hand side of this graph, you can see if I start on the left, I'm starting to draw, but then I get to this open circle. I have to pick up my pencil, set it down and draw the other side of the line, because this point gets jumped over. It's just one single point. If we filled it in, then it would be continuous on that interval, but it's not because of that point discontinuity. Okay, so let's do some practice. Oh, and before we move on, notice that if I look at this line here that we just did that discontinuity, the point discontinuity for, if I start on the left side of the line, I am decreasing. That is going downhill from left to right. Okay, so now let's look at a couple of examples and actually name the intervals. So again, we are only going to use the x values, our domain values, for the intervals for increasing, decreasing, and constant. So the first thing I want to do is I want to look at the graph and I want to see, do I see any relative mins or maxes? In this first graph, I do see a relative minimum there, and so I'm just going to write that ordered pair 2, 1, because this x value of the ordered pair is going to be really helpful. So now let's do some labeling on the graph. I'm going to start on the negative infinity side of the x-axis, that's the left side, and I'm going to read to the right. So when I start on the left-hand side, my line starts here, so I'm going to start there. I am going downhill, so that part is decreasing. Then when I get to this turning point, it starts going back uphill, so that part is increasing. So let's look at what we've got. And that increasing happens all the way to the right. That's positive infinity, far, far right. Okay, so the increasing part, it starts at this turning point, which is at 2. That's the 2 from my relative minimum. So I'm going to start at 2, and it increases to the far right. That's positive infinity. So I'm going to say the interval is from 2 to positive infinity. Notice here that I did not use any hard brackets. We are going to use soft brackets only for everything with increasing and decreasing. Don't let that mess you up from when we were talking about domain and range. Let's look at decreasing now. The decreasing starts on the far left side, so that's negative infinity, the far left, and it decreases all the way until I get to that relative minimum, which was at 2. So the decreasing stops at the turning point of 2. Now this one didn't have any sections that were constant, so I'm just going to write never there. And it didn't have any discontinuities. This line is one continuous line that I could draw without picking up my pencil, so I'm going to say there are none when it comes to types of discontinuities. Let's look at another one now. The first thing I'm going to do is look for mins and maxes. So I see a relative min right there. That's a turning point. So I'm going to list that. It's a max at -2, +5. The x value of -2 is going to come in handy for me when I am doing my increasing and decreasing. The second thing I'm going to do is start on the left, the negative infinity side. I'm going to read across the graph, left to right, and stop when I get to the far right, the positive infinity side of the x-axis. So let's start on our left. Over here on the left, it's going uphill, so that is increasing. Then once I get to that turning point, it starts going downhill, which is decreasing. I have a discontinuity happening here, and then it's a flat line, horizontal line, so that is going to be my constant section. So let's do some interval writing. The increasing section, that's this one over here, it starts on the far left side, which is negative infinity, and it increases all the way to that turning point, which was at -2. The decreasing starts after that turning point, so it's going to start after the -2, and it is going to continue decreasing until I get to this hole that's happening, this point discontinuity. That hole is at 3, so I'm going to write a 3 and my soft bracket. So we just talked about a point discontinuity, so I'm going to go ahead and write point down here. So I can answer that one ahead. And the only thing that I have left is the part that's constant. The constant starts at 3, and it goes all the way to the right, which means it goes to the right-hand side of the x-axis, which is positive infinity. Okay, let's look at one more before you try one. So the first thing that I see when I look at this graph immediately is that I see a dotted line, this vertical dotted line, and also this horizontal one. That means we are going to be looking at asymptotes. So we're going to have a discontinuity here. Okay, so the other thing that I notice is that this doesn't have any relative mins or maxes because it's not changing directions. If I start on the left side, the negative infinity side, and go to the right on the x-axis, so if I start here, I'm going downhill very slowly, and then I start going downhill more steeply. If I was riding a bike or something like that here, I would be okay at first, right? And then it would get really, really scary all of a sudden because I'd basically be riding my bike off of a cliff. But this is all going downhill. It's not changing and going up. There aren't any minimums or maximums, any changing points there. And if I look at this other one, if I was coming down this mountain from the left, I'm still going down. It's just a more comfortable down. It's not as steep. So there aren't any changes there, any turning points. So that means there are no mins and maxes. And we also talked about going downhill, which means this part is decreasing, and downhill from left to right, so this part is also decreasing. I didn't label anything with increasing, so I'm going to put never there. And I have 2 sections that are decreasing, so I'm going to have to give 2 intervals on my line here. The decreasing on the left, remember you're always starting with the left, is at the negative infinity side of the x-axis. And this decreasing decreases until I get to this asymptote, which stops me because I can't touch it. I just keep getting closer and closer to it. So I get really close to that -3, but I don't touch it. And I have to pick up my pencil in order to draw the other part of our function. So that's where our asymptote is. The decreasing for the right-hand branch here starts when you get to the other side of the asymptote. So I'm going to draw U for union, meaning that both of these are the decreasing intervals. I'm going to start it at the -3 because that's the left side of this one, not touching it. And it goes downhill infinitely to the right, which is our positive infinity. It continues to decrease. Now, it does get kind of weird when we get to this asymptote, but that's a y value, so we're not going to worry about that just yet. Range for this one would be the challenging piece if I was asking you for domain and range. Okay, so then constant, I didn't label anything as constant, so I'm going to put never here. And that answers all of my questions. So a couple of tips. Number 1, always look for mins and maxes because those will help you answer some of the questions. Second, label all of the parts of the graph like I did here with increasing, decreasing, or constant. And also pay careful attention to where you have discontinuities because that's going to mean that you have more intervals because of the discontinuity. All right, so in this video, you learned how to identify those intervals where the function's increasing, decreasing, and constant, and we also did a little bit of an introduction to 2 types of discontinuities, points and asymptotes. Go ahead and try those Now You Try problems now.